Okay, here's some more examples. So there's number 10, 11, 12 of our piecewise functions. So copy those down, or you can just pause your video and try to graph all three of those, and then we'll go back with the solution. So you can pause right now, graph, and I'll be right back. Okay, hopefully you graphed all those, and we want to check your work and see how you did. So let's get to work here. So here's number 10. And first of all, blue function, negative 1/3 x plus 2, and x is less than negative 3, so it's going to be over here on this side. So I could work my way back, but sometimes I just put a point in. Sometimes it's easy. I want to pick a number that's divisible by 3, so I'll try negative 6. So when x is negative 6, a negative 3 times a negative 1/3 times a negative 6 is positive 2. Okay, and then 2 plus 2 is 4, so my point would be here at negative 6, 4. So you can just try some points. It's pretty easy to put some values in. And then I can try another number that's divisible by 3, which happens to be negative 3, so that's fine. So negative 1/3 times negative 3 is just going to be positive 1, plus 2 is 3, so it's going to be this point here, negative 3, 3. Since it's not equal to, I put a circle there, and I get a couple of points, and I can just connect those. So lines are pretty easy. When we get to curves, it's a little bit different, so we'll talk about that when we get there, but that's for the future. It's going to go on out further this direction. Okay, and then we've got 2x plus 1, so I'll do the same thing at negative 2. What's 2 at negative 3? What's the y value? Remember, these are all y values. You don't have to do this, but it's good just to remember that these are actually y values equal. Okay, so at negative 3, negative 2 times negative 3 is negative 6, plus 1 is negative 5, so we're down here at negative 5, and it's equal, so I'll put a dot there at negative 5. So my point is negative 3, negative 5. That's an easy way to do it. And then as I go to 1, if I put 1 in here, 2 times 1 is 1. 2 times 1 is 2, plus 1 is 3, so there's my point. 1, 3. And that's also a dot, so I'll put a dot there. And I'll connect those. And there you go there. All right, and then my third function, the green one, y equals negative 1 minus 1 for greater than 1. So I'll put 1 in here, and negative 1 and negative 1 is negative 2. So when x is 1, y is negative 2. It's a circle. And I can try another point. Why don't I try 5? Negative 5, when x is negative 5, this is going to be negative 6. I'm sorry, when x is 5. Pardon me, I'll try 5. And that becomes negative 5. So when x is 5, right over here, what's the y value? Well, if I put 5 in here, I got negative 5, and negative 1 is negative 6, so it's down here. And I'll go right through there. And you see the slope is negative 1, so it kind of makes sense. It's going down 1 over 1, down 1 over 1, so that does kind of check. That's my green function, so let me use the right color here. And there you go. So there's piecewise function. Now you can check the domain, but I've got everything's covered, it seems, because I got dots here, circle there, dot there, circle there, so everything's covered. So my domain is negative infinity to positive infinity. And since these arrows are going straight down and straight up and everything overlaps, it looks like I've got the range is also negative infinity to positive infinity. So make sure you're aware of your domain and range. Okay, let's try another one. It's number 11 here, and it's equal to negative 3, so that's real nice. So again, these are just the y values. F of x is Other way is y. So you need to be able to graph all these. If you can't graph these, then you would have some issues there. So we assume that we all can graph horizontal or oblique lines, or even the piecewise function in this case. But we can always put points in. It's real easy to do that. So -3, so x is less than or equal to -4. So I'll put a circle there at -4, and y is equal to -3. Alrighty. Oh, sorry here. Okay, so y is equal to -3 when x is -4, and it's equal to, so I got a dot there, so I can go something like that. There we go. And it's kind of short, but I'll still use a ruler just in case. There's your blue function, and there's a dot there because it's equal to. Okay, now we have the absolute value. So I can just put points in. So when x is -4, what's the absolute value of -4? +4. So -4, +4. And 0, 0. And we know we just go straight down diagonally. -1 is our slope. Then when x is 2, what's the absolute value? 2, 2. So we've got something like this. We know our absolute value is like a v, so that's what we've got. So, sorry, I've got to make the angle so I try to keep it somewhat neat. There we go. So that's that part of the absolute value, but we're open here at the edges, at the ends I should say, because these are both not equal. So we've got circles, and then finally this one over here, 1/2. So again, I'll try a point. I'll try to find a point that's divisible by 2, because I got a 1/2 in front, and this works out nicely. So if I put 2 here, what's 1/2 of 2? 1, so that's -1 plus 5 is 4, so I'm at 4. And it's equal to, so I've got a dot there at 4. Oops. And then I could try another point, so let me try 6. What's 1/2 of 6? 3, so I've got -3 plus 5 is 2, and there's 0.62. So you could use the table of values, just find some points, and you're in good shape. So there we go. And it's greater than, so it's going to go diagonally down, or obliquely down, I should say. And you can see that the slope is down 1/2, so it's -1/2, so that makes sense. So you can always check it by using your slope-intercept form. So there we go. All right, so that looks pretty formidable, but it's pretty easy. All right. And here we've got a circle but a dot, circle but a dot. Should be a dot there because it's greater than or equal to 2. And if we trace this back, you could see that the slope is -1/2. So if we went back, we would go to 5. So there's your intercept. So there's always kinds of ways to check it. All right. Okay, just like over here, the intercept is 1, so you can check these. All right. So my domain looks like it's going to be all real numbers from -infinity to infinity. And my range, well, this looks a little odd because you might not see that, but this line over here is going to go it's going to keep going down. So this line over here is going to keep going all the way down. So it's going to keep going. So it's going to be actually going to go down to -infinity. So my range is going to go from -infinity. It's going to overlap with that. It's going to go all the way up until I get to 4. And since there's a dot there, it's going to be including 4. So this is actually the dominant function. It covers everything as far as the range is concerned, because it's going from -infinity, because it's keep going down, all the way up to 4. So that might be a little misleading, so you kind of watch that. Okay. All right, and one more. And this is a little bit easier, but just to see how these can look kind of neat, this is going to be -2 when x is less than -2, circle, so -2 when x is less than -2. It's going to be equal to the negative of the absolute value of x, so this is going to be like an a. So absolute value of 0 is 0. The absolute value of negative 1 is 1, but times a negative, so it's negative 1. So it's going to go right down here to 2 like this. And the same thing over here. Oops. That's so absolute value of 2 is 2, where the negative is negative 2, so 2, negative 2, so we've got something like this. And that's going to be like this guy here. Oh, shoot. Sorry about that. Fortunately, got a little bit of white out here. There we go. Kind of wipe that out. And that's just going to be an A. I'm going to write it over here so I don't get all my white out and smear everything all over worse than I've actually done here. There we go, something like that. Okay. And then it's an open circle here, and then it's going to be negative 2 when x is greater than 2. So that's going to be back to green. And there you go. Alrighty. Try to fill that in so it's a little bit more like it will look like before my faux pas. And there we go. So it looks like the domain is going to be negative infinity to negative 2, then negative 2 to positive 2, then 2 to infinity. And it looks like the range is going to go from negative 2 all the way up to 0. Actually, it is including 0. Because the absolute value of 0 is 0, so it should be from negative 2 to 0 like that. Sorry about that. Let me raise this up a little bit higher so you can see that. And you can zoom in on these if you have to. So the domain goes from negative infinity to negative 2. That's equal to 0, so it's going to be from negative 2 to positive 2, and then from 2 to infinity. So we have openings at negative 2 and 2, open circles. And then the range is going to go from negative 2 all the way up to 0, including 0. Okay? So hopefully those will give you some good insights as to what's going on. Okay, does that make sense?